Hi, good evening again. This is Gregory Hayes from Eshkol Data Protection. When the chips are down and you've had a serious outage, a corruption incident, a ransomware incident, they're going to be looking for someone who is responsible for backing up the data. Okay? And the worst situation you can confront is that you realise your proprietary backup systems fail, or the backup server itself has gone down, the cloud backup has failed, or the data was simply never backed up because of a breakdown in communication. Right? The data owner didn't communicate to you, the engineer, the importance of this data, and that's happened to me a few times, so I'm fairly careful in that area. In the last analysis, if you've got your data, even if it's not a perfect copy, you have options. But if you have no backup, you have no options whatsoever. I was recently involved, 3 years ago, I was involved in an emergency recovery of a critical banking system for a nation state. And there was a tremendous amount of negligence on the part of the operators and the backup operators who just had never checked their backups in a number of years. So the backup data was woefully corrupt in places. And I was able to recover the server in one of the minor databases, but the major banking database was beyond my capability to recover, and it was so frustrating because with a $25 tape, I could have had that banking system back probably within half a day. So in the end, they had to go to Oracle third-level engineers in the States and net backup engineers, net backup specialists, some of my former colleagues at Veritas. And believe me, I'm sure they paid out possibly in the hundreds of thousands of dollars because they were that was the only option. But the point of it is, they still had options, although they had been irresponsible in places. And although their data was corrupt, they still had the majority of their data, so there was options. I've been involved in other incidents where there's been no backups whatsoever. I was called in to a fairly large regional airline a number of years ago when ransomware hit their financial system. But they had chosen not to back up that system. So when ransomware hit, there was really nothing we can do. So the point of it is that if you take responsibility for your backups, you will always have options. Sometimes those options are not perfect, as in the case of the banking system, but in the end, they got all their data back. It was a bit of a tortuous route and it was very expensive, but they got that system back online in approximately 11 days, right? So all credit to the third level engineers from Oracle and the consultants and Veritas in that particular scenario. But if you've got no data, you have no options. So let's continue our series tonight, and we're going to just do a very basic equivalent on a Windows system to what we did last week on a Linux, Unix system. So we're just going to look at some basic principles and get a basic working model. You don't have to follow this explicitly, and you can chop and change. We're looking at getting the medium changer online. We've got a Dell TL4000, a Dell TL2000, and a HP G2. If I have time, I will demonstrate all of them, but I might not have time because I realised in the last video we went a bit over time. All right, and the idea is to get a basic working backup and to show you how actually easy it is. It's actually not that difficult. You've got to come against this false gospel that you hear from, well, sponsored by people who've got a vested interest, and once again, who should know better, that, oh, it's so difficult and complex. It's not. In the majority of cases, working with tape-based systems is extremely straightforward, and I'd argue it's a lot easier and intuitive than cloud-based systems, all right? And the advantage is that you verify the backups yourself. You know in your heart of hearts, you have the data. If the proprietary on-premise backup fails, the backup server goes down, the cloud backup fails, you've got the third line of defense, all right? So let's go over to the screencast, and I hope what you learned tonight it's really not rocket science, but some of us who come from different backgrounds, network engineering or Windows, for example, have maybe never touched the tape system, and you've got these questions, all right? So we will just look at where we can start and how we can get a basic backup going with a medium changer. And this one has 3 tape drives. This one has 2, maybe only 1, I can't remember. It's very easy to get confused when you're working with different tape systems. And this one's a small unit, which just has 1 half-height tape system. All right, so let's go to the screencast, and then I'll come back to you a bit later and we'll finish off with some closing comments. Thank you.
All right, so what we have to do here is just confirm the basics that the Windows system can see the medium changer in the autoloader, and the Windows server can also see the tape drive that the autoloader or medium changer encases. And I won't emphasize the command line here. We can use a Cygwin terminal, but I wanted, you see where my pointer is now. I'll briefly refer to that in a moment. But let's stick to Windows, since this is in the spirit of the game here for our Windows engineer colleagues. Let's fire up Control Panel and simply go to the Device Manager. And what will happen is that we should see this in the Device Manager tree. And sure enough, there it is there, medium changer devices. Okay, Windows, it presents as an IBM 3573 tape medium changer or autoloader. Now, it's an open secret. You might have remembered that the autoloader tape changers I showed you a few minutes ago are actually Dell, but they're just rebadged IBM. The only thing that's changed is the fascia plate. They're made in the same factory by the same people, I'm sure. Okay, so that confirms that the Windows server can see the tape changer, the medium changer or the autoloader, whatever you want to call it. Now remember, I've got 1 tape drive cabled up in that system. Here is the tape drive here, and it identifies it as, once again, an IBM Ultium half height 3580. That's an LTO5 tape drive. Okay, so from this we can elucidate the Windows server is happy. It considers those devices identified and addressable. So if Windows is happy, then our backup server or backup software should be happy, because the foundation is good. Right, so let's go to the next stage now and look at the actual utilizing some the Windows backup facility and also some backup software. Just very quickly, just before I do that, this is Cygwin, a Unix-like emulator that you can just download for Windows Server. And if I just do an ls dev nst 0, like we were doing last week on the Windows Linux system, we can see it identifies it there. It's emulated the device tree. If I do an mtf dev nst0 status, okay, it gives us should give us a readout on the tape, just as we would get under Unix and Linux. Alright, seems to be really want to think about that, so I'm not quite sure what the hold up is. Oh, there we are. Okay, it's identified the tape. This is the half-height Ultium as an LTO5. It's come in at a default block size as 32768. So that was probably set by the backup software when I did an earlier backup. Remember from last week I said there's 2 sort of default block sizes that we use. Now we have not got an equivalent of MTX to the best of my knowledge. MTX is the command line that addresses the changer, but there it is. So that's just a little aside. So let's go back on to the next stage now of using the Windows backup facility to make an initial backup. Once that backup archive is made, we look at moving it to the tape using any one of a number of backup software or freeware utilities. Alright, so we'll just stop there. Thank you. Okay, so we'll come to the next section, and what we'll do now is a quick backup using the Windows Server Backup utility. So the idea is we make a backup image file, and then we'll focus on moving it to tape. Historically, Windows Server Backup under NT had the ability to address a tape drive, but for some reason it was taken out of Windows when Windows NT was superseded by Windows Server. But the good news is the utility is pretty robust, pretty good. It's a bit clunky when you're trying to manage versions, but as a plug and play fire and forget utility, it is very good, very reliable, and it could very well save your life. And the important thing is, for a Windows person, it's a native Windows utility. It's not add-on, and it's bundled with all versions of Windows Server. So let's just start it up, and you can, if it's not apparent there, just its official name is Windows Server Backup, right there. All right, and this was on the sys tray, so it's come up immediately, but starts up after a few seconds, and you're presented with a window, which is the basic management interface. Gives you all your previous backups, their results, right? Now, Windows Server Backup prefers its own dedicated backup disk, which it puts its own proprietary reservations on. Will not let the operating system even see the file system on that disk. So this is excellent for security, and gives you an extra measure of protection from ransomware, because ransomware is programmed to look for shadow copies and shadow backups and every other sort of 200 and 250 types of data file, from Oracle to MySQL databases to Exchange files to document spreadsheets. But ransomware cannot attack something that it cannot see. So I would encourage you, if you've got the disk capacity, to dedicate a whole disk to Windows Server Backup, and then let it manage that disk. All right. Now, however, the other way of using Windows Server Backup was just letting it write a normal addressable sort of volume to a disk, and that's the methodology we're going to use tonight, because once we've made the image backup and put it on a normal disk, we can move it onto a tape, whereas there probably would be issues that trying to move a dedicated Windows Server Backup disk in the actual specified Windows format onto a tape. You could do it, but it's going to get a bit complicated and beyond the scope of this presentation tonight. So what we'll do is we fire it up, go to action, and we'll do a backup once. I'm not going to use the backup schedule options that I've used for previous backups. You can, but backup once will give us most of the facility we want. So choose different options unless you've already configured this and the schedule options work well. Okay, next, and we don't want a full server backup, because if you've got a decent sized physical server, your backup is going to be extremely large, might get into the terabytes if this is your first backup. Windows Server Backup will do a full system backup and image backup on its first pass, and then it does incremental backups automatically for a period of, like, I don't know, 30 days afterwards approximately, but sometimes a bit longer. The incremental backups will be very small and manageable. Okay, I'm not a great fan of full server image backups. I don't like the idea of trying to restore from images with regards that have all the drivers and the system partition on. I prefer discrete sort of volume file system level backups. I'll choose custom, and we're just going to go for a small one tonight. And at this window, add the items you want to back up. Just go into the file system. I'll just do a very small trivial one, back up that Dell directory. Normally you'd navigate and find your Oracle database, your SQL database, your critical file shares, and these are what you need to make sure you're backing up. Okay, right, so there it is, see Dell, go next, and we choose the destination, and we want to back up to a local drive. I'm not a great fan of remote shared folders. Backing up large backups over the network should be avoided if possible, and with good engineering and basic architecture and a bit of common sense, you can actually prevent a lot of unnecessary network backups over your LAN connection. Okay, so choose a local drive, and I'm going to put that image just on my E drive. I've got a bit of space there, that's fine. Okay, so that's ready to go. Hit backup, and Windows will then automatically synchronize all the options and everything and start your backup. This should finish in a minute or two because it's a very small backup. If you're doing a large backup of a large file shares or databases, you know, you could be running 4 hours to 8 hours to 12 hours on your first backup. So schedule it at night. Okay, so there we are. That's going through now, and it's just, as you can see, it's working with the shadow copy facility there. All right, but the great thing about this is even if your shadow copies get wiped out by ransomware, this backup will still be available and it'll be on the disk there. Okay, so it'll go through now, and we'll just wait for that to complete. Once that backup completes, now the reason it said I've transferred no data is that it's automatically done an incremental backup, because when I was preparing the video, I went through a few practice runs, and normally it would finish and there'd be about 120 meg there. It's saying 0 because it's done an incremental backup automatically, because it knows it's already got a full backup and no data's changed, so it's elected not to actually move any bits and bytes out there. So that's fine. So it still registers though as a successful backup. So now we've reached the stage where we've got a number of backups of that directory under the Windows backup image format, which generally is pretty open and can be mounted by your disk manager and accessed very easily. So now we're going to move that onto a tape drive. So let's close Windows image backup, all right, and just make a mental note that the backup was on E drive, and that's where the archive is. Okay, now we're going to start up Pyrius. Now this is one you can use. It's a trial version, lasts 30 days. You can use other facilities like Veeam, but Veeam I thought was a bit complicated for this video, and it does take a week or two to get familiar with the interface, the graphical interface of Veeam. You could use NetBackup. I believe you get 30 days or 60 days on NetBackup, but there are many other facilities out there that can write to tape drives under Windows that might be freeware or trialware, and if you know of a good one, by all means put it in the comments below. I've chosen this one because it's straightforward. All right, so what I'm going to do is just let me get rid of the previous backups just for a minute, so we can just go from scratch. All right, okay, so this is Pyrius full backup, and we choose create a new backup job, and we're going to add the items to backup, go for the path, and on the HP server we were in E drive. Let's see if we can find that backup. Now there it is, there's Windows image backup. Okay, I'll go one level down, which is the main container containing the full backup and the XML files which manage the incremental backups. Click OK. All right. I won't bother with any of these options at the moment, just take the vanilla, one size is all. When you have time, you can look at exclusions, which are very useful, and filters to filter out large media or audio visual files that are just unnecessary to back up, or other files that you know don't need to be backed up, and these can save you terabytes of space. All right, click OK. Right, now let's go to the destination, and we're going to add the tape drive. All right, add the destination to tape, and remember, Device Manager was happy with the configuration of the medium changer and the tape drive. So the backup software relying on Windows is happy, and it's the Device Manager's passed up the options here. It's addressing the tape drive as tape 0, that's the default name. Now we're not talking to the medium changer here, so it's not quite as sophisticated as some of the things we showed you last week under Linux and Unix. It's electing to talk directly to the tape drive, which is encased by the medium changer, but that's okay for our purposes. choose incremental because it'll do a full backup first automatically, but successive backups you want to be incremental, and these will be very small and manageable. Leave these options here every 7 days. Okay, click OK, and that should be fine. Now I think we're ready to go. Run the backup on schedule Monday. Choose the default time, 8 p.m. Okay. The advanced settings you can play around with. You might want to play around with compression ratios, which might give you a bit more mileage. Log files are a good idea. These other options are for you to decide and to experiment. I've only used this software 3 times myself, so I don't, purport to be an authority on Pyrius. I don't prefer to get an email, otherwise you're going to get snowed under. Go next. Before backup, we can run scripts, which can be useful. You can run possibly PowerShell or Perl scripts or Cygwin scripts, which can do things like encryption or perform certain actions. All right, click next. Take the default name. It's taking the default name of the server, HP Win 12B, and click OK. All right, that looks like it's happy with that. Now let's just see if it can run that backup. Let's click Run Backup. Run backup job. Yes, and there it is. It gives us a little log window, and it will now be start dumping that archive on the E drive. There you can see it's talking to the tape system, and it's rewinding the tape just to be on the safe side. Most backup softwares will do that, and it'll start dumping that archive and E drive to the tape in the Dell TL4000. There it is. It looks like it's running. All right, probably it's probably using a tar command. Later, as an exercise, we might look at extracting these files and just see if we can actually recover and read them without the Pyrius software. We might save that for a later video. All right, so there we are. Okay, and that has finished. Backup completed successfully. Right, now just as we finish the video, what I'll do now very quickly is come into my management interface. Most medium changes will have a management interface, and as I mentioned in the last video, they're remarkably good and straightforward. They're not clunky, they don't use exotic versions of Java, they don't gum up and fail, so they're a lot better than some I've seen for Cisco, Brocade switches and a few other network items around the place. So the IP address you can confirm from the front panel of your medium changer. Just there's a little LCD screen, and you can click that and get the network address if you're not sure of it. All right, come in as the administrator, and there we are. Here is the Dell TL4000. It's primarily useful for monitoring the library, like the status of the tape drives. Here, it's telling me that the tape drives are online. It's giving me here the speeds that the SAS tape drives are capable of. No errors, all right? So we see there's 3 tape drives listed. I've got 2 LTO5s and an LTO4 tape drive in this. Media retention, probably it got upset with the tape on a previous incarnation of a backup and maybe wants a clean. This generally is not really a deal breaker, so you don't need to be too concerned about it. Remarkably, there's not an easy way to clear these flags. Sometimes they clear automatically if you clean the drive, but yeah, that's the only little clunky bit I find. Now, manage the library, you'll use it generally for moving tapes, all right? So for example, drive 2 was the one we were addressing. It's got a tape named MRC019L5. So let's say I'm finished with that tape, I want to physically remove it from the medium changer. I can just put it into slot 1, click move, and then pull the relevant magazine from the medium changer. Okay, release magazine. All right, and you've got basically left and right options, and that would probably be in the left. I think that would be the lower left magazine, slot 1, and just click release. They're the primary functions. You can do some limited configuration here on the network, on the drives, and a few other things. You can't use these really to troubleshoot tape device issues. You cannot read to a tape or write from a tape using this facility. It's only a management facility for the medium changer. It can't really address the tape drive directly. It has no access to the SCSI SAS path. So you won't be able to use this to actually kick off a backup. So just keep that in mind. But they're a useful adjunct that can help you monitor and troubleshoot some issues. All right. So I'll finish there, and I'll come back with just some concluding comments, and that nearly concludes our video. Thank you very much.
All right, well, good evening once again. So there you have it, an introduction to open tape-based backup systems using Windows, and we see it's possible and not too difficult to do with just a bit of organised common sense. So what we did tonight is we verified the medium changer was online and the tape drive encased in that medium changer and was addressable by the HP Windows server. And then we proceeded to use the native Windows backup facility to make an archive. And then we used a third-party option. In this case, it was like Pyrius software, but you could have used Veeam, NetBackup, and probably a host of others, Amanda. But for simplicity and convenience, we demonstrated with Pyrius how to move that Windows backup image onto the tape. And as I said, we're not trying to give you formulas, just more thematic principles. You can vary, you might find better software or a slightly different way of doing things, and that's quite acceptable. But the important thing is you have that third level of backup in case cloud fails or your regular backup system fails, or is rendered invalidated by data corruption, or network infrastructure goes down, like in the Katrina level event in the States in 2005, which took out the regional infrastructure. And in that case, virtually all cloud backups are useless. Ransomware could take out the cloud appliance, or a firmware bug could corrupt, and this happened actually in Perth in Australia a few years ago with the Australian Department of Taxation, the firmware bug taking out a crucial SAN appliance. So that's why we need this, and it gives you control over your backup. And as you practice recoveries, it just increases your level of confidence. And more so with the events of the last few months with the COVID-19, we can see that a black swan that you and I had never even considered can come out of the blue and affect all your standard backup systems. For example, staffing could go down at even one of these huge cloud providers like Google or Amazon or Microsoft Azure. And I would never even consider what's happened in the last few months. And I come from Perth, Australia, the only place in the world, to my knowledge, that literal black swans exist. You can find them in Perth. Okay, the rest of the world has white swans. But I would not have thought of a black swan like the COVID-19. And the ramifications of that have been incredible. And they could propagate into the IT area and affect every area of your IT operations. So this is why it's crucial to have independent backup systems in parallel that you verify and that you know work. All right? So that's about what I wanted to cover tonight. Next week we might look at some more advanced scripting options, or we might look at encryption, because that's, if you can just get the basics of encryption, as I said last week, it puts you in a great position. Right? It means if a tape does go astray or is stolen, it's useless to the bad guys, because they can't possibly hack the encryption, and it's easy to do. So I hope you got some value out of it tonight, and until next time, as we say in the La PDR, bye-bye and copy idea.